Deploying Fortigate cluster on AWS. In this lab, our objective is to build a redundant and highly available Fortigate cluster on AWS. This will provide a protection and security for our virtual machines and other services that are deployed in the cloud. The tools we will be using for this lab are EC2, so we can host a virtual machine for the Fortigate itself, and CloudFormation, which is an infrastructure as a code, and CloudFormation uses JSON files to simplify and provision different AWS resources for you. There are hundreds of CloudFormation templates that you can use that will help you save tons of time on provisioning individual services to get your system working. And with VPC, we can build networks in the cloud, we can build subnets, internet gateways, and configure routing for our subnets. And finally, for the cost, the CloudFormation template we will be using for this lab deploys different EC2 instance of size C5x large as minimum. To make sure you keep that in mind, they are more on the expensive side, and you can use services such as AWS Calculator to estimate your total monthly payment for those devices. Now, our requirement to build this lab, first we need to subscribe to the Fortigate pay-as-you-go model. This is a page on AWS Marketplace that you need to agree to the terms of service and the pricing terms before you are able to deploy the CloudFormation template. If you skip this step, your CloudFormation template will fail. Next, we will need to create an EC2 key pair to use within the CloudFormation template. Next, we will deploy our VPC with internet connectivity. We need 4 subnets to finish this cluster. First, we need a management subnet where we give unique IPs for each firewall so we can separately manage them in a cluster. Second, we need an HA sync subnet because unlike connecting FortiGate clusters on premises where we use layer 2 Ethernet directly between the firewalls, in the cloud the sync or the clustering HA protocol between the firewalls uses a unicast IP, and each firewall will have a unique IP in this sync subnet. This subnet will be completely isolated and will be dedicated only for syncing the firewalls together in our cluster. The third subnet we need is a public subnet. This is where our firewall will have an interface facing the internet, so we can use the firewall for different things such as web filtering, DDoS protection, IPS protection. The firewall will front end everything, will have access to the internet, and all our virtual machines will actually be in our private subnet. This subnet will have connectivity to our local network, and all the public traffic will be sent through the firewall and will adhere to all the firewall policies that we create. And the last step is to launch our CloudFormation template, where we will have to provide input for all these requirements, and CloudFormation will take care of everything else and create everything else for us. Let's check it out. First, we need to access the GitHub page for Fortinet, and in here we will find a folder for our CloudFormation templates. And we can see the first option we have is a heartbeat. And here you have the liberty to choose which version you want to go with. Let's try the latest version. And here we will find that we can use either a single availability zone on AWS or dual availability zones. If you want to go with the dual availability zone option, you will have to create an S3 bucket and do some extra steps to get it to work. So for this lab, we will just use a single availability zone. We will still have redundancy within a single data center. And here we have 2 different JSON files for 2 different templates. We could either use an existing VPC, so we can create our VPC manually, create our subnets, and create our internet gateway, do all the routing, and have the firewall just deploy the EC2 instance and configure the heartbeat in between. Or there is an option to deploy even the VPC and the subnets for you. But for this lab, we will create our own VPC so we can control everything our way. And here we can take a look at our topology. We will be using a single availability zone in AWS, and we will create 4 different subnets. This will be our heartbeat subnet between the firewalls. And then we will have our private subnets where we can deploy different EC2 instance and different EC2 services not directly exposed to the internet. Then we have our public subnet where we have a route to the internet gateway so we can have internet connectivity. And finally, we have a separate management subnet where we have a unique IP for each firewall that is accessible even from internet for emergency situations. And Fortigate will use this specific script to configure the heartbeat between both firewalls. If we compare this cloud heartbeat script to the script we use to configure HA cluster on GNS tree, the only one difference we see is set unicast heartbeat enable, and then it lists the IP address from the heartbeat sync, and this is how the firewalls communicate to each other because there is no typical layer 2 connectivity on the cloud, the same like normal network you would have in a data center or in your home. In this way, the firewalls will use these unique IPs from the sync subnet to talk to each other and sync their configuration and policies together. Now let's peek into the template file. This CloudFormation template for existing VPC FortiGate setup has different parameters we have to input during the process, such as the VPC ID, the subnet that we created for our public, for private subnet, for sync subnet, and for management subnet. And those are the 4 subnets that we talked about as a requirement, and they will be inside a VPC, of course. And now we can see the first issue we have. This template uses a Fortigate license file. That means this template is based on bring your own license model. And as we have no license right now to use, we could not use this bring your own license model. We have to choose a different version than 6.2. And version 6.0 is formatted correctly because it has existing VPC, bring your own license, and pay as you go. And also, if you want the CloudFormation to do everything for you, including the subnet creation, you could use the new VPC one. And from here, we also have launch stack buttons that take us directly to CloudFormation, where the template will be launched. First, let's create our dependencies, and then we will come back to launch our template in CloudFormation. Now I have my VPC ready. It's assigned 10.0.0.0/16. Under subnets, I have 4 subnets. First, our private subnet is the biggest size. It's a /22. This way we have a bigger size subnet that we can deploy virtual machines and different services. And then we have our Fortigate management. This is a small subnet. So after you subtract the 5 IPs for AWS, you are left only 11 IPs, where we only need 2 IP addresses, one for each firewall, so we can remotely manage them separately from other traffic. Next, we have our public subnet, also small. We only need a 1 public IP in the cluster that will be shared in between the cluster, and the master Fortigate will always have the cluster public IP address. And the last subnet we need is our sync subnet, where each firewall will have a unique IP, and it will be used to sync the configuration and the cluster information between both firewalls. And next, we'll move into route tables. And for the route tables, we need 3 different route tables. You can use the default one that gets created with your VPC for the private network, and make sure that this private route table is connected to your private subnet. Once we have our Fortigate unit ready, we can come back here and modify the default route to send the traffic into the firewall. But for now, it has only the default local connected network. The second route table we have is for our public subnet. This has been associated with the public subnet and the management subnet because both of these subnets will have public IPs attached to it. For our management subnet, we need to create public IPs so we can access the firewalls remotely from the internet. And for our public traffic coming from the virtual machine and different AWS resources, we'll use this public subnet to NAT and get into the internet using our firewall policies. And in the route table for the public subnet, we have a default route to the internet, which is our internet gateway. And finally, the sync subnet is not connected to anything beside the local network. That's where it needs to talk to the other Fortigate unit, and it does not need to connect to anything else beside that. And this has also been associated only with the sync subnet. So now we have all our subnets ready, we have our VPC ready. We can move into EC2 so we can get a key pair. And once we go in the EC2, we can find our key pairs on the left. And we just need to create a key pair, give it a name Fortigate. and create the key pair. And it also downloaded the PPK file for us, which is the private key. And finally, we need to get to the AWS Marketplace and activate our subscription for the Fortinet pay-as-you-go model to make sure we are choosing the correct version. If we go down to the pricing, we should be able to see a software pricing. That means we are paying for the software on demand, so we are choosing the correct version. Also, you're getting 15 days for free for the first time you use this image, so make sure you take advantage of this trial as well. You can just click continue to subscribe, and then it will let you know now you are subscribed to the software, and you can continue with deploying resources using this subscription. So now we can go back to our Fortinet GitHub page, and we can choose to deploy our pay-as-you-go existing VPC template, and we can launch stack. And because Fortinet headquarters is in the West region in California, so they are using the Oregon region to deploy this resource. Now remember, we deployed our VPC on a different region. So if I open VPC now that the region had changed and check my VPC or subnet, I don't have the same subnets that I created on the other region, so I have to choose the same region that I came from. So before you continue with the template, make sure you are choosing the correct region from the top. So I have to go back to North Virginia, and the template will load the same way on my region. Now if I go back to my VPC and make sure I am in the correct VPC, yes, I see my 4 subnet. We are good to go. And now you can click next. You can give a stack name. This is only for CloudFormation. And here we have to define our parameters. We have to input everything we created so far so CloudFormation can know where to deploy all these resources. So first we need to choose our VPC. I see here already my 10.0.0.0/16. It still asks me to input this one more time. And here is the easy part, because all we need to do is just select the subnet from the list. So I can choose public for my public subnet. For my private subnet, I choose the private subnet. For the sync, I choose the sync subnet. And for the management, I'll choose the management subnet. Now we have to choose our instance type. And we can see that the smallest instance we can deploy is C5X large, which is very expensive compared to what we need. But this is the lowest they provide in this template. And we can choose this as the lowest option we have. For the FortiGate management access over the internet, you can choose to allow it from all IP addresses, or you can define it to something more granular. For now, we need to allow it from everywhere. And next, we have to choose our availability zone for our instance. We are using the single availability zone for our setup. And in order for us to tell which availability zone we are using, we have to go back to VPC. And we have to check the 4 subnets that we created. And in the far right, we will see that all these subnets are in region 1C. So we just need to come here and choose our 1C availability zone. And next we need to define the router IP from each subnet. This will be the first IP address in the subnet. So if we go back to our subnet that we created, on the public subnet we are using 10.0.20.0/28. So our router IP, the AWS router IP, will be 10.0.20.1. For the private will be 10.0.0.1. For the sync subnet, it did not ask us for the gateway because the traffic in the sync subnet doesn't need to talk to anything else outside the subnet. So there is no need for it to know what is the gateway. For the management subnet, so our router IP will be 10.0.21.1. So we just need to manually define this. So now I added the 3 router IPs for each subnet. I can move on into the interface configuration of the FortiGates. First, we have to provide the IP address from each subnet for the FortiGate in a CIDR format. So we have to mention the CIDR mask in the end. And we have to do the same for the FortiGate number 2. So let's start by the interface configuration for the first FortiGate unit. From my subnet 10.0.20.0/28, I'll give the IP address .5, and for the private subnet, I will also give it .5. For the sync subnet, I will give it .20, and for the management subnet, I will give it .5 as well. So now we have 4 IPs for the FortiGate unit number 1 in each subnet. Now let's move into FortiGate number 2 and let's choose the second IP address on each subnet. So instead of .5, we will choose .6 and .6 in the private IP. On the sync IP, we will choose .21. And for our management subnet, we'll choose .6. And finally, we choose our cluster public IP. We can grab our subnet in here and we will use .7 for our public cluster IP. And for the cluster private IP address, we will choose 10.0.0.7. Now we also have 4 IP addresses for the second firewall from each subnet. And finally, we have the 2 floating IP addresses that are assigned to the cluster and are always owned by the master firewall. So now once we choose next, we can assign different tags to our stack. We can give different permissions, or we can go ahead and go for next. And in here, there is also a link to estimate the cost, where you will see that each firewall will cost $124 a month. And this only covers the EC2 instance. We also have to pay attention for our internet traffic, and we can see the outbound data transfer is 1 GB free per month per region. Anything after that you have to pay per gigabyte. So keep that in mind, this is not the total cost. So once we verify the pricing, we can come back here to our CloudFormation, and this is the review page for all the parameters we choose during this CloudFormation setup. Finally, we need to go all the way down and allow the CloudFormation to create a rule to do all this work. And then we can create a stack, and in a few minutes the CloudFormation template will complete. And if we switch to Resources tab, we will see the different resources that had been created during this process, starting from the 4 interfaces from each FortiGate unit, and the IAM rule, a security group to allow access to the interfaces, and 3 different IP addresses, 1 unique public IP to manage the FortiGate number 2, 1 unique IP to manage the FortiGate number 1, and 1 cluster public IP. This IP will be moving between the FortiGates. Whoever is master will own this public IP address. Finally, under outputs, we will see all the information we need. This is our username, our initial password. This is the FortiGate cluster IP address. This is the FortiGate number 1, FortiGate number 2. So let's try to log into our cluster. And here it also lets us know that the default password is the instance ID. So we can log in with admin and the instance ID of the FortiGate, and then we will be forced to change it right away. And now I'm directly on the FortiGate and I'm running version 6.0.5. We go under network interfaces, and here we will see the 4 IP addresses from each subnet. We have our public subnet, private subnet, sync subnet, and management subnet. The only downside for using this on AWS is you do not get to see the public IP address directly on the FortiGate page. You actually have to go to EC2 so you can see which public IP address is assigned. But first, let's verify our heartbeat and cluster status under System, Heartbeat. Now we see both firewalls, the 4 interfaces on each firewall. We can see the different IP addresses we created initially. And we will see that the sync is not yet completed. So let's give it a few minutes until both FortiGates have been synced to each other. Now we can go back to EC2 to verify the resources that had been created. And under EC2 instance, we see the 2 FortiGate. We can rename it to a friendly name. For FortiGate number 1, we have our 4 private IP addresses from each subnet. Notice that we also have 2 secondary private IP addresses. This is the cluster IP addresses that we created during the CloudFormation template. And now because the FortiGate number 1 owns the cluster and is the master of the cluster, he actually is owning these secondary private IP addresses. And we can see that the main firewall also has 2 different elastic IPs. One is the cluster public IP address, and one is the management IP for this specific firewall. Now, if we compare these IP addresses and setup to the FortiGate number 2, the FortiGate number 2 only has the management IP address to manage this specific unit directly from the internet, and it has 4 private IP addresses from each subnet, and it does not have any secondary private IP address. So if the FortiGate number 1 were to fail, the Fortigate clustering protocol will move these secondary private IP addresses that belong to the cluster to the secondary firewall and will update the routing table and the elastic IP address mapping for this cluster IP address to point to the secondary firewall. Now both firewalls are in sync, everything is green, everything is working properly. Now we have been managing this Fortigate cluster using the cluster public IP directly. If I were to log into this IP address for the Fortigate number 1, so I'm getting the same result by accessing the cluster public IP address versus the Fortigate number 1 unique management public IP address. And if I want to control the backup unit, which is Fortigate number 2, I can directly get to this IP address as well. And this IP address will allow me to control the Fortigate number 2 unit, which is not actively passing any traffic right now. And now we have everything created for the Fortigate unit. We can go back to our EC2, and under network interfaces, we will see a list of the 8 interfaces that were created for this Fortigate. As these generated names from the CloudFormation template, so I went ahead and modified all the names from the generated names to something more friendly, so we can modify our route tables to the traffic from our private subnet, including our virtual machines and different AWS resources. Will have a default route to the private subnet of the Fortigate number 1, which has this interface ID. We need to copy that, and then we will control the traffic using our firewall policies to connect to the internet through port 1 for our public subnet. So now we can go to our VPC, route tables. Our public subnet still has the internet gateway default route, so it has direct internet connectivity, and that's how we are reaching our Fortigate interfaces. And our private route table right now has no way to connect to the internet. So we need to modify this, and we're gonna need to add our default route for our private instance. And now we will send it, instead of sending it to the internet gateway, which will be unfiltered traffic, unprotected, we will need to send it to a network interface. We can either paste the interface ID that we copied earlier, or we can directly choose from here because we have now these friendly interface names. We need to send this to Fortigate number 1, interface number 2 for our private subnet. And now we have a default route to the Fortigate number 1 private IP address. We can go back to our cluster and we go under policies, and we can see there is already a policy created by default on the Fortigate allowing traffic coming from port 2. That's where we are sending our default route, and it's sending it to our port 1 where the internet lives, and it allows all the IP addresses. We can modify this to match only our private subnet, and we can also add different security policies, which we will do in a different lab. That is enabled, so all the traffic coming from our private subnet sent to the public interface will be natted to 10.0.20.7. This IP will be natted on AWS side to the public IP address. And this way we have our internet connectivity from our private subnet protected by the firewall, and none of our virtual machine or private resources is connected directly to the internet. Now let's try to emulate a disaster scenario where one of the Fortigate fails, and we will see how the Fortigate clustering protocol operates on AWS and how does it move the interface IPs in between. And we can go under system and we can do a reboot. This way the Fortigate number 1 will reboot itself, and if we check back into our route table, we still have our route sent to the interface for B1B. And if we refresh the page right now, notice how the default route has automatically been switched to the interface ending with 53BA. That was not the interface that was there previously. And if we check what that is, that's Fortigate number 2 private interface. So the clustering protocol had changed the route table with any reference to the old network interface of Fortigate number 1, which is currently unavailable, and modified it directly to the Fortigate number 2 interface. Also, if we go under instance, we used to have the secondary private IP addresses under here, and we used to have 2 public IP addresses. Now the Fortigate number 2 owns the private IP addresses of the cluster and also owns the cluster public IP address. We refresh the page for the cluster public IP address. and relog into the firewall, now the public IP address of the cluster is responding from FortiGate number 2 after the failover situation. And if we go under System Heartbeat, we will see that the FortiGate number 2 is now master, and FortiGate number 1 has revived already, but because override is not enabled, it did not take over again. So if we want FortiGate number 1 to always take over, we can come here to our FortiGate number 1, and we can configure directly from here, config system HA, and we see here that override is disabled. So if we come here and enable override by putting the command set override enable and end, now we have override enabled on the FortiGate number 1. We just need to go back to FortiGate number 2 and give it a reboot as well. And once FortiGate number 2 is going down, the FortiGate number 1 will detect. Clustering protocol will do the same scenario again. If we refresh our EC2 page, we will see that the FortiGate number 1 owns the secondary private IP addresses again and owns the elastic IP address of the instance. The route table has been updated accordingly. That's how you configure a FortiGate cluster on AWS Cloud using CloudFormation to simplify and provision all these resources with the minimum amount of configuration on your side. Thank you for watching.